All right, so this video is all about how to calculate using cubes and squares. And so it is a little bit different. So the idea is, let's just say you have, I don't know, 1 square meter. So it's 1 meter this way and 1 meter this way. And so within this, the idea is, okay, if it's 1 square meter, there's 100 centimeters in a meter. So is it just 100 square centimeters to fill this? Now the question is no, because remember, if 1 meter is, let's just say, that left to right distance, and so that means that there's 100 centimeters that would go here, right? But if we, and I know I'm not drawing to scale, but if we fill this with 100 square centimeters, that's only covering that distance. So you didn't actually cover this whole section. You still got 99 centimeters to go going this way. So the idea is 100 square centimeters does not equal 1 square meter. And so this is the kind of big difference or big thing with cubes and squares. And so the way it works is instead, it's not just 100 centimeters or square centimeters is equal to 1 meter, but it's 100 squared. And so that's the big thing here. And so with cubes and squares, you need to square the number in addition to the units. All right, so let's look at how this actually works a little bit more with some calculations. So first up, we have a classroom is 25 meters by 10 meters. Okay, well, we have 25 meters by 10 meters, which means that this is 250, notice I'm keeping track of sig figs here, square meters. And so now let's go through and calculate this area in square feet. And so to do that, it starts off with our factor labeling as 250 meters squared. Now, just so you guys know, I know we talked about calculating with sig figs. You really only have to round or worry about it at the very, very end. So even here, if I just said, okay, it's 250 and I didn't worry about the sig fig part, your final answer at the end does need to be rounded to 3 sig figs. All right, so now that we have 250 square meters and we're trying to get to feet, remember the big conversion factor that allows us to switch between the metric system and the American system is the fact that we need to know that there are 2.54 centimeters for every 1 inch. So this conversion factor is what we need to try and get to, which means that we need to convert meters here to centimeters first. Now, I know it's meters squared, but the factor labeling process still stays the same. So that means that what we need to do is, if we're converting meters to centimeters, we would set it up like this. And then it's 100 centimeters for every 1 meter. And now this is where the squared part comes in. And so we actually square everything. Now, really, the only number that it affects is the 100 because 100 is now squared. And the 1, yes, it's being squared, but that doesn't really do anything because we know 1 squared is still 1. All right, so that gets us from meters squared to centimeters. Now we can use our conversion factor that we drew, or I wrote down a second ago, and that will allow us to go to inches. And so now, as we convert to inches, it would be 1 inch on top over our centimeters on the bottom. And now we can plug in our numbers, so it's 1 inch for every 2.54 centimeters. Now let's correct it for the squared part, so we square everything. There it is. And now let's go through and finish with converting inches back to feet. And so as we do that, we know for every 1 foot, there's 12 inches. And since it's square inches, we square everything. And now this should give us our answer in square feet. Now, before we do that, let's talk about how we actually plug this into our calculator. And so the way that I like to do it is I would do 250 times, and then in parentheses, I would do 100 squared, close parentheses. Then I would do divided by, so for calculators, I guess it would be a slash. So slash, and then in parentheses again, I'll do 2.54 squared, close parentheses. Then again, times, or I guess it would be divided by again since it's 12 squared on the bottom. So it would be divided by again, then 12 squared. And so that should be how you have to plug this calculation into your calculator. Now you can do it all as one big thing, or if you wanted to, you could do it as 3 kind of separate steps where you take your answer from the first part and then plug it into the second part and then the third part. It's whatever you would prefer. But when you plug this in, and you should actually practice plugging this in, not just watch the video, but when you plug this in, you should get 2,690 square feet. Now keep in mind, we did keep our 3 sig figs that we started with. So you do have to watch your sig figs a little bit while you guys are solving these problems. All right, let's look at our next one. So our next one is, what is the area of a pie that has a diameter of 0.9 feet? And what is the area of that pie in square inches? Okay, well, our first step should be to say, okay, if the diameter is 0.900 feet, we should solve for our radius in order to actually use our area equation. So it should be 0.9 feet divided by 2, which should give us 0.450 feet. And so this, remember, represents our radius. And now that we have our radius, now let's plug it into our area equation. Now remember, our area equation is pi r squared. And so now as we plug this in, this would be pi times our radius, 0.450 feet squared. And now we can't really use this yet, so let's plug it in to our calculator, including using pi, and that should give us 0.630 square feet. All right, so that gives us our area of the pie in feet. Now let's do it in inches. And so if we're doing it in inches, we would start off with our 0.63. Oops, sorry, this is 0.636, not 630. So 636. So let's take that 0.636 square feet. And as we convert it to square inches, just like before, if we're trying to get to inches, we know that inches would be on the top, feet would be on the bottom, so that way the feet cancel. But since it's squared, remember we have to square everything. So it's 12 squared, 1 squared, inches squared, feet squared. And now as we plug this in, it should be 0.636 times 12 squared, which should give us 91.6 square inches. All right, let's look at another example. Now here, one of the things that we need to know, and you should probably add this to that list of conversion factors. The big thing here is that 1 cubic centimeter is the same as 1 milliliter. And so I know that some of you guys may have actually got caught up on the factor labeling question, which I believe was number 6 from the worksheet, because it was missing this kind of tidbit of information. So this is an important kind of side note that you guys should use. The other one that you guys can kind of use or assume a bunch is that this is also equal to 1 gram. Now you can assume that as long as you aren't given a density. If you're given a density in a question, you have to use the density. But if you're not given a question and you're expected to jump from like centimeters or milliliters to a mass like grams or pounds, that's an assumption that you can make. Anyways, let's talk about our question. How many cubic centimeters of Arnold Palmer can be found in 1.75 gallons? Okay, well, if we're talking about cubic centimeters, the big thing here is that 1 cubic centimeter is the same as a milliliter. So we essentially need to convert our 1.75 gallons into first liters, which we can then convert to milliliters. And so if we're converting gallons to liters, part of one of our conversion factors was there are 3.78 liters for every 1 gallon. So now our gallons will cancel, leaving us with liters. Then our next step should be to convert liters to milliliters. And so for that, we know that there is 1,000 milliliters for every 1 liter. And now that we're in milliliters, let's turn it into cubic centimeters. And there is 1 cubic centimeter for every 1 milliliter. And so this would be our calculation. And now we go through and plug it into our calculator. And as we do that, we get 6,615, which rounded to 3 sig figs would be 6,620 cubic centimeters. All right, and now let's do one last one, tricky one, just because it's not directly converting units, and we have to use the information in the question. And so it says, a garden hose flows at a rate of 15.5 gallons per minute in order to fill a backyard pool. If the pool's dimensions are 30 feet long, 15 feet across, and 3 feet deep, how many hours will it take for the pool to be completely filled with water? All right, well, I know that this is a whole lot of information, but one thing that I will kind of point out for you guys, if you're confused on where to even start with this, is you always, or you want to try and avoid what I'll call complex units. Now, a complex unit is one like the 15.5 gallons per minute. So remember, if it's 15.5 gallons per minute, that means we could use it as a conversion factor as 15.5 gallons over 1 minute, or 1 minute over 15.5 gallons. So that's just something to keep in mind. So we don't want to start with that because it's giving us a conversion factor that we can use throughout our question. So with that in mind, what we should be starting off with is the dimensions of our pool. So if we start with the dimensions of our pool, we can actually take those three and get a volume of our pool. So we're going to start with that as the length times width times the height. And so this would be 30 times 18 times 3. And for this one, we have to, we're going to ignore the sig fig rules for a minute. But that's going to give us a volume of 1,620 cubic feet. All right, so now that we have cubic feet, one of the things that we can do with cubic feet, and it kind of ties back into what we were talking about earlier, is we know that 1 centimeter cubed is equal to 1 milliliter, which means that in order for us to take our cubic feet and turn it into a volume, that should be our next kind of overall goal or our next step. And so that means we're going to start off with our 1,620 cubic feet. And in order to get it into a volume, we need to get into centimeters first, or cubic centimeters. So that does mean we should have the goal of trying to get from feet to inches first. And we know that there are 12 inches in every 1 foot. And then remember, since it's feet cubed, we cube it all. Then our next step should be, since we're in inches, let's go from inches to centimeters. And so there's 2.54 centimeters for every 1 inch. And then since our units are cubed, again, we cube it all. And now that should get us into cubic centimeters, which once we're in cubic centimeters, we can turn that into milliliters because we know that there's 1 milliliter for every 1 cubic centimeter. And so now that we're in milliliters, now we can actually work towards, because remember the question is how many hours will it take? Well, the one kind of tidbit of information that we're given that has a time in it is the 15.5 gallons per minute part. So our goal here should be, okay, if this is gallons per minute, our goal should be to find gallons or turn our milliliters that we have so far into gallons. And so with that in mind, now let's go through and let's turn our milliliters to first liters and then to gallons. And so if we're going first to liters, we know that there's 1 liter for every 1,000 milliliters. And that gets us to liters. Now we can get to gallons by saying there's 1 gallon for every 3.78 liters. And so now that we're in gallons, now let's go through and say, okay, now we can use that flow rate or the 15.5 gallons per minute. Now, earlier we wrote those out, right? And we said it could be 15.5 gallons over 1 minute or 1 minute over 15.5 gallons. Now, that second one is the one that we're going to end up using because that's going to allow us to take something like gallons and turn it into a time. And so now, as we turn that into a time, that gives us 1 minute for every 15.5 gallons. And now finally, before we finish or before we start plugging stuff in, let's just take a second. What's our question asking us for? Hours, right? So in the end, we can't just stop at minutes. We need to convert minutes to hours. And so for that, we know that for every hour, there is 60 minutes. All right. And I know that that was a lot, but there it is, the calculation. Now we just got to worry about plugging it into our calculator. So go ahead, practice plugging this one in because this one is, believe me, a doozy. It's one of the longer factor labeling questions that you can actually get. And so when you plug it in, go ahead and double check your answer. You should get 14.6 hours. All right, that's it for today's video, and I'll see you guys later.